So let's get straight to the paper. So section A, which is like question number 1, we have 10 multiple choice questions and we must choose the correct option. So 1.1, they're telling us that when a spaceship moves at a constant velocity, it simply means that the resultant force that is acting on the body is 0. So this phenomenon is best explained using Newton's first law, Newton's second law, third law, universal. The best here will be Newton's first law, because something will continue in a state of rest or move in a continuous motion unless acted upon, meaning that the net force is 0 for as long as it's constant rest or constant motion. Then 1.2, a physics textbook is placed on top of a mathematics textbook as shown in the diagram. The reaction force to the weight of the fixed textbook is it the force of the maths textbook on the physics? No. The force of the physics textbook on the maths? Nope. The force of the physics textbook on the earth. That would be the best option. Okay. The force of the math on the earth? No. The physics on the earth. So the reaction force or the weight of the physics. Okay. And then 1.3. 1.3. Which one of the following sketch graphs correctly shows the relationship between acceleration as well as the net force? So we know that F net is equal to ma. So net force is directly proportional to the acceleration. This one is already out. This one is also out. This, some bit of truth, but the starting point limits it. So it's also out. I'll take option A to be the correct one, directly proportional. Then 1.42 hypothetical planets XY have the same mass. The diameter of planet Y is twice that of X. Okay. If the acceleration due to gravity on the surface of X is G, then the acceleration due to gravity on the surface of Y is going to be. So in this case, what matters is the distance, okay, the diameters. So if this is twice the other, meaning that one is going to be half of the other. Okay, so if it is half of the other, what is going to be the acceleration due to? We know that G is the same as Gm over R squared. Okay, so the mass can be double, the mass is just the same, mass is not changing. So the best answer here would be option B. Okay, whereby the mass is twice, or sorry, the diameter is twice, meaning that the diameter of the other one is a half. Okay, but then we also need the radius. What is a half of a half? Which is a quarter. So meaning that it is a quarter of G. Okay, then 1.5, the block moves at a velocity v across the horizontal surface AB. If it moves down the slope BC, the coefficient of the kinetic friction is the same along that. Which of the following statements about the frictional force experienced by the block will be true? Okay, so the question is talking about the kinetic friction experienced by the block. So what we know is that the kinetic frictional force on the slope will be greater. Nope. Kinetic frictional force, okay, of the slope is equal to this, the horizontal. Nope, the force cannot be the same because remember with the slope, you're dealing with just the component of the normal force. Kinetic frictional force of the slope will be smaller than that. This is very correct. This is wrong. So option C makes more sense. Then 1.6, we have 4 forces that are acting on a point as indicated. Okay, the magnitude of the components of the resultant net force in the horizontal and the vertical. So with the horizontal, we shall have 1 and 3, which is 4. With the vertical, we're going to have 2 because it's 4 minus 2, which is a 2. So a 2 in the vertical and then 4 within the horizontal. So Fx, we said 4. This is wrong, this is wrong, this is wrong. This is correct. That is fine. So option D becomes the best. 1.7, a small test charge positive Q is placed exactly halfway between two identical positively charged X and Y, each having that. So they're asking us that the test charge Q1 will remain where it is. So if these two are identical, there's going to be repulsion, okay? And if there's repulsion, whatever is happening at Q should be a zero. So in other words, it needs, I would say, remain wherever it is because no force is pushing it away. So it remains where it is. So option A is the best. It cannot move to X, not to Y, and not vertically down or up. Then 1.8, we have diagram that's showing the north pole of a bar magnet that is approaching the end A of a solenoid. Which of the following statements about the polarity of A and the direction of the magnetic field inside as the North Pole approaches? So we saw this in our reviews in one of the papers. I think it was Eastern Cape, where we looked at the induced magnetism. So if this is the north, meaning that A should definitely have, is it going to be a North Pole or a South Pole? I don't know, because they're telling us in the diagram, the North Pole of a bar magnet approaches the end. Okay. Which of the statements about the polarity of A and the direction of magnetic field inside the solenoid is correct as the North Pole approaches? So A is going to be 1, a North Pole, and then the field is going to be B to A. So I'll go with option B. Then 1.9, in the circuit shown below, bulbs X and Y are identical, okay, meaning that they have the same resistance. The following correctly describes the initial change in the total resistance as the reading of the ammeter when switch S is closed. So we know that already initially there's current that is flowing through X when switch S is open and there's no current in this. So what is going to be the change in the total resistance and then the total on the total current? So the resistance, since the two are in parallel, must decrease. Okay. And then the current must increase because when resistance is small, then the current is more. So D is the best option for that. And then 1.10, which one of the following graphs best represents the relationship between electrical power as well as the current of in a given ohmic conductor? So power and the current, are they constant in what? In a given ohmic conductor. No, it's not the same. So as the current increases, the power must kind of, does it increase or decrease? It must increase also, but not in this manner. Here, the power is constant. The power is decreasing. Power is increasing in a linear way. I think I'll go with option D, which is kind of exponential. Then question 2, we have three forces, M, P, and G. They're acting on a point located at the origin. The Cartesian, the forces in the directions as shown below. So is the force M a scalar or a vector? Number one we know is that anything called a force will always be a vector quantity. And then define the term resultant force. So we say that the resultant force is a single force, okay? A single force that has the same effect, as two or more forces combined. More forces combined or all together. Then 2.2, if the resultant horizontal component is this, can we prove that the horizontal component of M is that much? All right. Let's see. So I'm going to break this down into 300 sine of 20, 300 cos of 20. I'll break this down in this manner. Will it make sense though? So it's up this direction, meaning it is M, the sine of 30. This is M, cos of 30. Okay, and then this is the 500 sine of 50, but downwards, and then this is negative 500 cos of 50. Okay, so let's combine the horizontal alone. Okay, so when I focus on the horizontal, so we know that our F net of the horizontal is 26,93. So I'll say that my 266,93 should be equivalent to the 300 cos of 20, and then plus the m sine of 30, and then I subtract the 500 cos of 50. So I need to make m the subject, so I have to transpose and move everything to that other side. Okay, so we can use the M30 or the M60. There is no problem there. Okay, but with the 60, it's going to be a cos, but I'm using a sign there. So when I move everything that side, meaning that M is going to be the 266,93 minus the 300 cos of 20 plus the 500 cos of 50. And then this, I'll divide it by the sine of 30. So this gives me the 612,83 as the question simply wanted, 612,83 newtons. All right, then 2.3. There is a light string that is suspended from the ceiling. X, an object of mass 8 is tied to the string, horizontal force 60 newtons exerted, causing the OX to experience tension. System is in equilibrium. Can we draw a closed vector diagram showing all the forces that are acting on point? So one thing we know is that if we try to resolve this, okay, so if this is the tension, okay, we know that there is a weight that is acting down there, and then this is like the applied force. So let's combine everything. So tension is slanting that direction. And then we know that this is the weight. Okay, and then we can have this. So tension is moving upwards, and then this is the weight, and then this is going to be the force applied with an arrow. Okay, so that is how we would have that, and then this would be our theta of interest if you have to. Then calculate the magnitude of the tension T. Okay, so with the tension T, what do we do? Because they're giving us just 2 marks. So let's use the Pythagoras and say that T squared is equal to W squared plus the force applied squared. So our weight is going to be 8 multiplied by 9,8. Everything is squared, plus the force applied, which is 60 squared, under the square root must give us the tension. So if I do that, I'll end up with a 98,72 newtons as our tension. Question number 3, a wooden cabinet of unknown mass M rests on the back of a tip-up truck. The back tilts slowly until it makes an angle of 30 with the horizontal. The cabinet remains stationary. The maximum static force or friction between the surface and the truck is given as that. Can we state Newton's first law? So we know that Newton's first law tells us that a body, okay, remains at rest or uniform motion in a straight line unless acted upon by an external force, or some people can call it by a net force or by a non-zero force. Then 3.1.2, they want us to calculate the mass of the wooden cabinet. So one thing we know, okay, about this, we shall use the F net being equal to the MA. So what I'm going to look at is the static friction. So Fs is going to be the mu s multiplied by the normal force component. So we have the 294 being equal to, did they give us the coefficient? That's what they want us to find. Okay. And then the component of the normal force is going to be mg, cos of theta. So that's going to be m, which we don't know. Ne? Do we have the m? No. So it's m multiplied by 9,8, and then the cos of 13. M multiplied by that cos of 13. But one thing we know is that the mu is not going to make sense in this case. Why? Because the mu, wait a minute, what are we looking for? Is it the coefficient or are we looking for the mass? Why should I mix up? I need to do one question at a time. So let's attempt 3.2 first. 3.2 is asking for the mass of the wooden cabinet. So with this mass, we shall say for maximum, okay, Fs maximum should be equivalent to Fg parallel, okay? So for it to slide or for it not to go, so the friction is upwards and then the Fg parallel is down. The two must be equal. So this one is mg, the sine of 30. So do we know the size of m? Yes, they told us. It is, where's the size? Where's the size? The wooden track. They are not being specific. We don't know the size. We only know the force. So which means that 294 is equal to m, which we are looking for, 9,8, the sine of 13. So that's going to be 294 divided by, this is going to be 4,9 is equal to m. So meaning that our m must end up being 60 kilograms, okay, if we are to round off that. So if m is 60, then they want us to get the coefficient. So then we can apply whatever we were doing initially. So with that, I'll jot it this side and say that Fs max, okay, static friction max, should be equivalent to mu multiplied by the normal force. So this was a 294 is equal to the mu, which we don't know. And then this n is going to be mg, the cos of theta. So 294 is equal, why don't we divide? The mass, we got 60, 9,8, and then the cos of 30. So the mu that I'm getting for a round of 2 decimals will be 0,58. Okay, then 3.1.4, the angle of 30 is now decreased. Okay, how will this affect the following? Number one, how will it affect the coefficient of friction? So the coefficient is not affected, okay, remains the same. Coefficient is not affected by the angle of inclination. So it will stay the same. And then the frictional force is going to be affected, okay? So in this case, it's going to increase. The moment you decrease the angle, the force must increase. So we shall say that as theta decreases, okay, this cos theta must increase, okay? And if that cos theta increases, even the normal force will increase. Reason is the force directly proportional to that. So even the force friction will increase. Then 3.2, a person stands on a stationary lift. The combined weight of the person and the lift is 5,000 newtons. What is the question asking for? 3.2.1, how will the tension in the lift cable change when the lift accelerates upwards? So the tension must increase when it's moving upwards. And then the cable of the lift suddenly snaps while it's moving upwards. Explain the observed movement within the lift. So we're saying that the lift, okay, will continue going up as by Newton's first law of motion. Then it will go downwards afterwards. So he's saying the lift continues upwards. It will continue upwards due to inertia. Before it goes down. All right, question number 4. Two crates A and B with masses 8 and 5 respectively are stationary. On a rough surface, the crates are connected by a string. When the applied force on the 8 kg block, both blocks will move. Okay. Then they are asking us to state Newton's second law of motion in words. So we say that when a net force acts on an object, the object will accelerate in the direction of the net force. And then the acceleration is directly proportional to the net force, but inversely proportional to the mass. So that's how that should be stated. They want us to draw a free body diagram for the 5 kg. So with the 5 kg, we're seeing the tension, we are seeing the frictional force, the normal force, and then the weight. So we're going to say that that is tension. I'm going to say that is friction. This is weight. And then that is the normal force. So that is what we need for the 4 marks, 4 forces. And then 4.3, they go on to tell us that the magnitude of the frictional force of A and B are 7,68 and 4,9 respectively. Calculate the magnitude of the acceleration of block B. So whether the acceleration is for block B or block A, it has to be the same for as long as the two bodies are moving together. Okay, so for us to get the acceleration, we can look at the entire unit, or we can look at the individual unit. Okay, whereby we look at body A and also focus on body A. Sorry, body B. So when I look at, let's say, block A, my force applied, okay, my force applied, I'm just going to use the F cos of 30. Do we have the force? Yes, it is 80. Okay, so which means it's 80 cos of 80, sorry, 30 minus the tension, minus also the frictional force should give me the MA. Okay, so F net is equal to MA. So it's saying 80 cos of 30 minus the frictional force. So friction for A is 7,68. 7,68. We are subtracting the tension, which we don't know, should give us the mass of A, which is 8, and then the acceleration. Okay, so this is what I'm getting. Then when I simplify and make T the subject, move everything that side and to that side, I'm going to end up with a 61,60 minus 8A. Let's call that equation 1. Then let's look at the block B. Block B, if the direction is to the right, then it's going to be the tension minus the frictional force, just those two. Okay, I'll still say that F net should be equal to MA. So the tension plus the frictional force should give us the mass and the acceleration. But it's fine. Let me just make to the subject also. So the mass here for B is 5. Okay, so it's a 5 minus the frictional force, which is 4,9, plus the MA, which is, why am I doing that? So this must be a 5A first, minus 4,9. Does it make sense? So it was a T. This is supposed to be a minus. Then when the cross it becomes a plus. Okay, thank you. So that's equation number 2. Then let's equate the 2. So 61,60 minus 8A should give us 5A plus 4,9. Let's transpose the A to that side, meaning that 13A should give us, what will it give us? It will give us a 61,6. We are subtracting the 4,9. That is 16, which is a 7. So that is going to be 0, 1. That's going to be 6. So it's a 56,7. Divide both sides by 13, meaning that our acceleration is going to be 4,36 meters per second squared. So that becomes the acceleration of the system, but also the acceleration of each body. 4.4, can you define the term kinetic frictional force? So we know that a force that opposes motion of moving object that is relative to the surface. So we say this is a resistive force to the motion of an object, okay, but relative to the surface. So there has to be motion, first of all, between the surface and the object before it can be kinetic friction. So how will the following change affect the frictional force on crate A? If we increase the angle, okay, the frictional force will definitely decrease. And how do we explain that? We just saw it up somewhere up there, that if you increase the angle, increasing the angle, what will it do? Increasing the angle will increase the vertical component. The vertical component. So as the vertical component increases, the normal force decreases. What we saw that side was that if the cos theta, or if the cos of an angle increases, the theta increases, the cos theta becomes smaller and smaller. Okay, question number 5. A delivery person is standing on a smooth frictionless surface and pushes a 15 kg crate to the left. The person has a mass of 60 and applies a force of 45. Can we state Newton's third law? Okay, so we know that when object A, okay, when object A exerts a force on object B simultaneously exerts an oppositely directed force of equal magnitude on B. Okay, so when A exerts a force on B, B must simultaneously also react with the same force, but in just the opposite direction. Then write down any action-reaction pair of forces that are evident within the scenario. So the action pair that I'm seeing here is number 1, the force of the crate, okay? Force of the crate on a person. Okay, the crate is exerting a force on the person. Okay, and then the force of a person on the crate. That's number 1. The other one is the weight and then the normal force. That could also be another pair of forces. Then 5.3, draw a free body diagram showing all the forces that are acting on the crate. So we have the applied force that is acting in that direction, the frictional force will be acting in this direction, the weight down, the normal force should be upwards. But what did they say? They said a frictionless surface. So we don't have any friction there. So meaning that our diagram should be normal force, should be the weight, and then we shall have the force applied. Okay, then we move on to the next one. What is the magnitude of the force that the crate exerts on the person? So it's going to be 45 newtons, but in the opposite direction. Then explain why the crate and the person move in opposite direction. So we're seeing that the forces are equal in magnitude, but act in opposite directions. So what this question means is that for you to push the crate to the left, the person should be pushing themselves to the right. Okay, that's what the question meant. Then question 6, planet Mars has a mass of this much and its moon Phobos has a mass of this much. And then there's a radius of 11,1 kilometer. The magnitude of the gravitational force between the two is given as such. Explain what is meant by weightlessness. So weightlessness is basically a sensation, okay? A sensation that must be experienced. Sensation experienced when all contact forces, okay, when all contact forces are removed. So if we remove all the contact forces, then whatever you feel, as if you're moving up, as if you're moving down in a confused state, is what we call weightlessness. Then 6.2, calculate how far apart Mars and Phobos are. So they want us to get the distance between them. So from Newton's law of universal gravitation, we can get R squared. So R is going to be the square root of G M1 M2 over F. When I substitute, I have 6, why don't I write here, 6,67 times 10 to the negative 11 times the mass, 6,4 times 10 to the 23. Other mass is 9,6 times 10 to the 15. We're dividing it by the force, 4,6 times 10 to the 15. Everything is under the square root. So when I punch this into the calculator, I'm getting a 9,44 times 10 to the 6 meters. Okay, then distinguish between mass and weight. Some people confuse the two. Okay, so we know that mass is the amount of content, okay? The amount of content that will be found in an object. And then weight is the gravitational force. Okay, weight is the gravitational force the Earth exerts. The Earth exerts on the surface. You can see near the surface. Then calculate the gravitational acceleration of the moon Phobos. So we know that G will be given as Gm divided by R squared. So 6,67 times 10 to the negative 11 multiplied by the mass of Phobos, which is 9,6 times 10 to the exponent of 15. We're dividing it by the radius. Okay, so what is the radius of Phobos? They told us it is 11,11 multiplied by 1,000, which is 3.100. Okay, so that is 3.100. We square that. So meaning that our acceleration is going to be 0.05 meters per second squared. So small. Question 7, two identical metal spheres are suspended on a light inelastic cotton thread. Sphere T carries 5,4 nanocoulombs. Sphere S carries negative 8,2. Explain why the spheres are suspended on the cotton threads. So the reason is just to prevent loss of electrons. So prevent electron loss, or some people will call it electron leakage or discharge. Then 7.2, calculate the number of electrons on S. So for us to get the number of electrons, we can use N is equal to Q over E. Okay, so the charge on S is 8,2 times 10 to the negative 9, but it's a negative. The electron charge is negative 1,6 times 10 to the negative, I think it's 19, which is correct. Then our N, punching this in the calculator, should give us 5,125 times 10 to the exponent of 10 electrons. So this is the number of electrons that we have altogether. Then draw the electric field pattern around T. So T is positive. So the field lines should be seen moving out of the sphere. Let's just have that. So the arrows must be moving out since it's positively charged. So that is how it should be done or drawn. Then 7.4, spheres are brought into contact and then separated. So when spheres are brought into contact, they're going to have to share the same charge afterwards. So negative 8,2 plus 5,4. The answer we divide by 2. Okay, whatever answer we get here is what each sphere is going to have. But let's see what the question is asking. From which sphere will electrons move? Is it from T to S or S to T? Now we can see that S is more negative. T is more positive. So when you talk about electrons that are basically negatively charged, they have to move from where they are rich, which is S, and then move to that. So it's going to be S to T. Then use the law of conservation of charge to calculate the new charge on each of the spheres. So that's what we were doing up there. So negative 8,2 nanocoulomb plus 5,4 nanocoulomb divided by 2. So this is going to give me negative 1,4 nanocoulomb, which can also be written as negative 1,4 times 10 to the negative 9 coulombs. Okay, then question number 7.5, use your knowledge of electrostatics to explain the phenomenon below. When the air is dry, your hands feel a small, sharp electric shock when you touch a metal doorknob after walking along the carpet to the door. So this should be explained just in terms of what we call the static electricity. Okay, so we can say that static electricity is formed when the air is dry. Okay, it's formed much more better when the air is dry or the humidity is kind of low. Then water molecules do collect various materials. Okay, so he's saying the water molecules can collect on surfaces, and then this prevents build up of electrical charge. All right, something of the sort. Question number 8. 3-point charges D, E, and F are shown in the diagram below. We have the magnitude. They're telling us that QE is a negative 4 microcoulomb. Then we have a positive 5 microcoulomb and then a positive 2 microcoulomb. Can we state Coulomb's law in words? So we know that the magnitude of electrostatic force, okay, exerted by one point charge Q to another is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So it's basically that formula, Q1, Q2 over R squared. Then 8.1.2, can we calculate the magnitude of the net force that is exerted on QF due to the presence of that and that? So in this case, we need to find the force, EF, the force DF, and then find the resultant in each case. So when I start with DF, I think that will be the best one. Okay, I'm using this formula. I don't need to write it out. I just need to substitute. So 9 times 10 to the 9. The Q1 is a 4 times 10 to the negative 6. And then, why am I using 4? We said DF. So it's a 2. Okay. And then we have a 5 times 10 to the negative 6 divided by, we need to change this to meters, divided by 1,000 to 0,003, but squared. Okay, so this DF gives me an answer of 8,000 newtons, okay? Then I need to get the force for EF. I'll do the same thing, 9 times 10 to the 9, multiplied by now 4 times 10. What is wrong with me? 4 times 10 to the negative 6 multiplied by 5. They wanted this as a result of D and E. So we said DF. Okay, that is a 2 and the 5. And then, okay, so this is times 5 times 10 to the negative 6. And then we're going to divide this by Let's hope I'm not mixing up things. 0.04. Okay, this is 0.04, but no, there are two zeros after the comma. 0.04 squared. Okay, so this gives us the 5625 newtons, okay? Which one is which? Because this is a 20, that's 18 divided by 16. Okay, then for us to get the resultant, we must use the Pythagoras, né? So it's going to be 8,000 squared plus 5625 squared under the square root. So our resultant must be 9779.60 newtons. Then 8.2, 2-point charges A, B, each with this are stationary on a horizontal surface. P is R meters from A and 2 R meters from B as shown. Can we define electric field? So we know that this is basically a region of space in which an electric charge experiences a force. Then they want us to draw the resultant pattern as a result of A and B. So this is a negative, that's a negative. So they're going to be repulsion. Okay, repulsion. Okay, repulsion. So the field lines should be coming in just like that. Okay, then they want us to calculate the magnitude of the net electric field at P is 30. Can we determine the size of R? So we know, I'll just jot it aside, that E is given as KQ over R squared. So if I focus on the A, it's going to be 9 times 10 to the 9 multiplied by 2 times 10 to the negative 12. Okay. And then I'll do the same that side, which is going to give me the same answer, but the distance, remember, in this case, it's a R. Okay. And then that side is just a 2R, meaning that the E of B is going to be 9 times 10 to the 9, 2 times 10 to the negative 12 over 2R, but squared. This was R squared. Okay, then for me to get the E net, I'll get the EA minus the EB, meaning that we're going to have a 30 being equal to 9 times 10 to the 9, 2 times 10 to the negative 12, no, it's times, over R squared, we are subtracting. Okay, 2 times 10 to the negative 12 over 2R squared. So you can multiply through by 2R squared. Okay, so that we can get rid of some things. So if I say 2R squared, 2R squared, and then 2R squared. So it's going to give me 60R squared. This and that, this and that. And this will cancel that. Then I'm only left with this, subtract that, and then I'll divide both sides by 60. Then I find the square root, which means that my final answer should be 0.02 M. Why am I multiplying by? No. I cannot multiply by 2R. It should be 4R squared. That is wrong. Okay, it should be, this is 2R but squared, which means it's 4R squared. Ne? This is 4R squared, and then this is 4R squared, meaning that you have 120R squared. This cancels that by 2.1 by 2.2, and then you have a 4.5 up there. This will cancel that. So when you divide both sides by 120 and then find the R, we should get the 0.02 meters, okay? All right, so that is what we were meant to do with that question. Then 8.2.4, calculate the magnitude of the net electrostatic force that an electron would experience if it was placed at point P. So we know that the force is given as E multiplied by Q. So it's going to be 30 multiplied by the electron charge, which is 1,6 times 10 to the negative 19, which gives me an answer of 4,8 times 10 to the negative 18 newtons. Question number 9, in the circuit below, the battery is having an EMF of 12. There is an internal resistance of 0,2 ohms. The resistances of connecting wires are negligible. Can we define the term EMF? So EMF is basically the energy needed, okay, or some people can say the work done by the battery per unit, oh, let's just call it per Coulomb, not per unit, because we're moving the current per Coulomb, but we can say unit. Yes, per unit charge passing through it. And then when S is closed, the potential difference is 11,7. When S is closed, the potential difference is 11,7. Can we write down the value of the internal voltage? So we know that the internal voltage is going to be, initially it was 12. Now we're subtracting 11,3, which means the internal voltage is 0,3, because the battery EMF was 12. Now we're having 11,7. Then calculate the current within the battery. The current within the battery. So I can say that V is equal to IR. The voltage of the internal is 0,3 is equal to I. The internal resistance is 0,2. So meaning that my I is 0,3 over 0,2, which must give us a 1,5 amps. And then the effective resistance of the parallel branch in grade 11. Okay, effective resistance of the parallel branch. So when we look at the parallel branch, we're having the 10 and the 15. So we can use the product over the sum. So 10 times 15 over 10 plus 15. So which is the same as 150 over 25. And what do we end up with? It's just the 6 ohms. Okay, so that is what the question wanted there. And then they want us to get, lastly, the resistance R. So resistance R is going to be in series. So meaning that it's going to be 6 plus R as the total resistance. But now with this, I can just only use the EMF formula and say that EMF is I into R plus the small r. So our EMF was a 12. The current we found is a 1,5. So I'll divide it by 1,5. It's giving me the effective resistance of the external 6 plus R. The internal is 0,2. Then 6 on that, which means a 12 over 1,5 minus the 6,2 should give me the Ohm's law. And we know that Ohm's law tells us that current is directly proportional to the potential difference. And then which one is the independent? So in this case, independent must be found on the horizontal, which is the potential difference. And then use the graph to calculate the resistance. So resistance is more like the gradient. So what we know, we can look at this point here. Okay, because I'm seeing that is the best point. Alternatively, we can use the entire graph, whereby you look at the 0,9. 0,9 is ending up with, okay, so we know that V is equal to IR, meaning that R must be the same V over I. So the potential difference, but in this case, we have current over the potential difference. So which means we have to say 1 over that entire thing, okay? So let me start with the current over So with the current over, which one can I use? Which one can I use? That is kind of exact. Let me use this one. So if that's 1,5, 1,6, 1,7, this is 1,8. Okay, 1,8 is going with 0, 0, what? 6, 1, 2, 3, 4, 5, 6. So 0,62. Okay, change in current, which is 0,62, divided by the change here, which is going to be the 1,5. Now 1, this is 1,6, 1,7. So it's 1,65. No, 1, because it's 1,65. And then when you reverse it around, that 1,65 divided by 0,62, what do we end up with? Let's see with our calculator. We're saying that 1,65 divided by, not 25, 1,65. I'm dividing it by 0,62. It gives me 2,6, 2,6, 2,66. Okay, so my resistance is going to be 2,66 ohms. The 9.2.4, we're being told that we have an electric heater that is marked with a power of 3,000. Okay, what is the cost of heating the room for just one day if the electricity costs 70 cents per unit? So we need to get how many hours are there in one day, which is 24. Ne? So the power is going to be 3,000, which is the same as 3,000 divided by 1,000, which gives us 3 kilowatts, meaning that 3 units per every hour. I guess that's what we're going to say. So it's going to be 3 times 24. 2,66. Okay, so my resistance is going to be 2,6. Ohms. The 9.2.4, we're being told that we have an electric heater that is marked with a power of 3,000. Okay, what is the cost of heating the room for just one day if the electricity costs 70 cents per unit? So we need to get how many hours are there in one day, which is 24. Ne? So the power is going to be 3,000, which is the same as 3,000 divided by 1,000, which gives us 3 kilowatts, meaning that 3 units per every hour. I guess that's what we're going to say. So it's going to be 3 times 24 and then multiplied by 70 cents, which is 0,7. That must give us a 50 rand and 40 cents. Okay. Question number 10. The diagram below represents the current conductor. Draw the magnetic field pattern around this. So in this case, we're going to see the field lines. or the pattern in this sort of direction. Just one or two is just enough, ne? So you're gonna have something like this. I would be lying if I kept that. So let's just put it in that sort of direction. Okay, so that's what we needed. And then state Faraday's law of electromagnetic induction in words. And so we know that the magnitude of the induced EMF across the ends of a conductor will be directly proportional to the rate of change, okay, in magnetic flux, okay, change in flux over the change in time. So the rate of change in magnetic flux linkage with the conductor. Then consider a solenoid that's having 9 turns with unknown radius. The solenoid is subjected to this Tesla. The face is perpendicular to the magnetic when the field is uniformly switched to the 12T over a period of 2 minutes, and the EMF of this is induced. They want us to get the change in the flux. So you know that the change, we can use the EMF and the phi, the change in the phi over the change in the time. So our EMF was 0.3 negative. This is negative. We're saying this is going to be 9. Let's start by getting the change in flux over the change in time. 2 minutes, which is like how many seconds? That's going to be 120 seconds. So our phi is going to be negative. No, negative and negative will give us a positive. Ne? So 0.3 multiplied by 120 divided by 9. So our change in flux becomes 4 Weber. And then they want us to get the radius of the solenoid. So in that case, we're going to use the magnetic flux linkage formula, whereby the change in flux should be given as the B multiplied by the A and the cos of theta. Okay. But this B is going to change. Okay. So B final minus B initial. So I'll say that 12 minus the 0.12 multiplied by the area. Okay. What shape are we talking about? Consider a solenoid with a radius. So if it is a radius, which means it is circular in nature. So that's going to be pi radius squared and then the cos of 0. This must give us the answer that we got, which is the 4 Weber. And then just do the cross multiplication of just the division. So that our R will be the square root of 4 over, this is 12 minus 0.12 pi. I think that is that because the cos of 0 is just a 1. So when I punch that, I should be able to get the 0.33 meters. All right, so that brings us to the end of this paper. I wish you guys all the best in your preparation for paper 2. Bye-bye.